Hello, welcome to this micro lecture on the activity at the neuromuscular junction. This video will walk you through the release of acetylcholine and its effects on the muscle cell's sarcolemma. You've probably been told that the skeletal muscle requires nervous system input to contract. Well, the neuromuscular junction here is where that takes place. It is where the conversation between the two happens. So for background here, the neuromuscular junction involves two major components. It includes the axonal bulb here at the end of the axon on its axon terminal. And this is where the acetylcholine is stored and from where it is released. The second major component is a specialized region of the sarcolemma known as the motor end plate, or also called the junctional folds. We say it is specialized because it contains the receptors for acetylcholine. Now, although this axonal ending comes very close to the muscle cell, they don't actually touch. The space between the two is called the synaptic cleft. So these are the major components here of the neuromuscular junction. Now, this is what actually happens. A nerve impulse travels down the axon and reaches the axon terminal. When it gets to the axon bulb, it causes voltage-gated calcium channels to open up. Calcium floods into the cell, and when it does, that calcium allows the vesicles containing the acetylcholine to carry out exocytosis. They fuse with the plasma membrane and dump their contents into the synaptic cleft. That acetylcholine travels across the cleft, binding to its receptors here on the motor end plate. These receptors are ligand-gated channels, and when acetylcholine binds to them, they open up, allowing, importantly, sodium to flood into the cell. Once sodium enters the muscle cell, it changes the resting membrane potential. It makes the resting membrane potential less negative or more positive. That change in the resting membrane potential is called the end plate potential. And if the acetylcholine stimulation is sufficient, that may lead to the generation of an action potential. Now, the acetylcholine doesn't hang out in the synaptic cleft on its receptors forever. Its effects do end, and there are three major ways in which their effects are terminated. One way is that the acetylcholine simply diffuses away from the synaptic cleft. And if it's no longer in the cleft, it doesn't bind to its receptors, doesn't have an effect. A second way is that enzymes break down the acetylcholine and rendering it no longer effective. So the enzyme acetylcholinesterase degrades the acetylcholine and again makes it ineffective. A third way is that the acetylcholine is taken back up into the axonal bulb. This is called reuptake. The acetylcholine is transported back into the axon terminal. Thank you for listening to this brief description of the activity at the neuromuscular junction.